Alright, so we will go over more definitions. So here we are going to do, um, we are going to look at the main types of data. So, see, types of data. Okay, so in statistics, we a lot of the times we deal with numbers, numerical values, but that's not always the case. We we do have non-numerical values, and we do look into those data. So we call those um, qualitative or categorical data. Okay, so it's in. Alright, so I'm just gonna write down the other type and let's compare these two. And here we have quantitative, and numerical data. Okay, so this is the one that we always think about. So these involve numbers, right? And whereas this qualitative data does not involve numbers. Okay, so let's look at some examples. So say we're looking at I don't know, we can say hair color, right? It's it's impossible for us to define hair color in terms of number. Like, how are you gonna measure the color? You're not gonna say, oh, black is number one or brown is number two. That's just not efficient, right? So we just break this down into, I don't know, we can say black, blonde, brown, and red, so on and so forth. So we divide it into different categories, and that's what the title suggests, right? Categorical data. That's how we do it. And say we're looking at hair color, then we would have to count the number of people with black hair, blonde hair, right? And then we would use some kind of number here. But the main thing here is the topic itself is not numerical. So what I'm trying to say is it does involve some numbers, because we can say, oh, 3 people have black hair, 4 people have blonde hair, 7 people have brown hair, and 2 people have red hair, right? So it does involve some numbers counting off, but the main topic here is the topic itself, right? Black, blonde, brown, and red. It does not involve any numbers. So that's how we divide it. That's the qualitative or categorical data. Um, or we can look at some other examples. We can say, so we can say that we are looking at employment, right? So we can say employment, we divide it into, I don't know, just employed or unemployed. And again, we don't use any numbers dividing these two categories. And some other examples would be blood type, right? We have 4 blood types, four main blood types, A, B, and O. So these are some examples of qualitative data. And now let's move on to qualitative. Qualitative data. Alright, so qualitative data is the one that can be measured, right? Can be measured. So what are some examples? Oh, sorry. can be not measurement but measured. Measured. Okay, so examples would be no, you know what, before we go into examples, let's just look at two types of quantitative data, right? So first we call it discrete, and these are the ones that we can count, we can actually count. And we have something called continuous, and this is more like a spectrum. Okay, I'll explain what I mean by this. Right, count meaning example of this would be let's think. Oh, how many people are in your family, like number of family members. You can actually count them up, like I have 1, 2, 3, or 4. It could be like that. You're not going to say I have 3.5 and 1 is on the way. It doesn't make any sense, right? So that's how we do discrete. Discrete is countable, and you can break it down into distinct gaps. So either like 1, 2, 3, or 4, right? Or it doesn't have to be a whole number. Like it could be 1.5, or it could be 1. I don't know, like 2.5, or whatever it is. It doesn't matter as long as it has certain interval, right? Like it can be, like, let's think of an example with 0.5. Can't think of anything right now, but let's see. Say you're looking at what's there? I can't think of anything right at the moment, but you get the concept of it, right? It has to be distinct. It has to be separated, right? So that's what it means by discrete. And if you look at continuous side, this is more like a spectrum, right? So it's like a number line. So it's true that you might be able to get 1, 2 whole numbers, but there are infinitely many numbers, possible ways of getting these numbers. So these are infinitely many well, should I say infinitely many intervals. So an example would be something like average. So say we're looking at test average. You might be able to, if you're lucky, you might be able to get 70 or 75, right? But it's possible to get 70.25, right? You never know what you're gonna get. So that's what I mean by spectrum. It's continuous, and these are all the possible answers or possible values you can get. So those are called continuous. Another example would be something like height or weight. Well, these two, it depends on the scale. Like some of you might say, oh, I weigh 200 pounds, but my scale just says 200, doesn't say 200.2 or 200.5. So doesn't that mean this is discrete? The answer is no, because the actual value is not 200. It's rounded up because of the scale, right? So if we're looking at the actual value, it might be 200.4516, right? So these are infinitely many. These are infinitely many. Like these values doesn't have any limitation to what it can be. So that's what it's called discrete and continuous. So these are qualitative and continuous, qualitative and quantitative data. All right, so now what we can do is we can look at how we organize data, right? So let's look at something easy, I guess. So we see that there are types of data, and we want to organize it or display it in a nice way so we can see the values, right? So for example, let's first look at categorical, right? Categorical data. So going back with the hair color example, say that we have let's just say we have 10 people in our class. Let's just break it down. Hair color, this is hair color, and this is number of people. So let's say brown is 4, say black is 3, we're just assuming, right? Red is 1, and the rest blonde is how many is that? 7 and 8, so 2. So in total, we have 10, right? Alright, so this is a chunk of data. So we see this, and I mean, it's not that bad since we have only 10 people. But imagine if we have like thousands and thousands of people. If we have 1 million, do you think it will be easier to see and categorize these? I think it will be harder, because if you see this number, right, 4, 3, 1, and 2, it doesn't really hit you unless you draw something to visualize it. So that's how graphs and charts come into play, right? So we use these options to visualize and help us understand better what the data represent. Okay, so let's look at some definitions. So here I just label this as number of people, and that is correct, but in statistics we call this frequency. So this is just how often it occurs. So how often, or how many in this case, so you have to put it into a context. So in this case it will be how many people have brown hair, and that the answer is 4, right? So that is frequency. And now we're gonna look into something called, let me just write it down here, relative frequency. Okay, so relative meaning you're comparing all the numbers here with each other, right? So this is not relative because this is absolute, right? It doesn't matter how many are there, how many totals are there, or how many people with black hair are there. It's just 4 by itself. It represents the number of brown hair. But when we're looking at relative frequency, everything is related. Everything is interconnected. So if you mess up one thing, it will change everything. So how do you get relative frequency? Well, relative frequency is frequency in the category, meaning the frequency that we're looking at, the absolute frequency, right, over total is the observation, right? Total observation meaning here total number of people, right? So let's let's look at the relative frequency for these data, right? So we have brown, black, red, and blonde. So brown is 4, right? The frequency in the category is 4 over total observation, which is 10. So this is 0.4. Same thing, 3 over 10, 0.3. You get to consider 0.1 and 0.2. And what happens if you add all these numbers? You get 1. So that's a characteristic of relative frequency. If you add all relative frequencies, you get 1. So this is kind of like probability. I'm not sure if you're familiar with the concept of probability, but probability always adds up to 1. So 1 meaning like 100%, right? This is all the chances, all possible ways combined together. So a relative frequency adds up to 1. Alright, so let's look at some other examples. You know what we can do here, for categorical data, most of the time we use something called the pie chart. And this is kind of obvious, right? So pie chart looks like a pie, that's why it's named after it, right? So it's pie chart. So what we can do here is these are really easy examples. I know you guys are waiting for like challenging stuff, but these are the basics. So let's just get through this first. Pie chart look like this. So you just draw a circle. That's a decent circle, right? I guess. So and you just divide it according to this. Just look at the relative frequency. I know in this case, it's easier to see because we had the total number as 10. It's just same thing as this. But what if you had like 563 people and you have 10 people for this? That it's really hard to visualize how the percentage of it, right? So in terms of percentage, it's easier to use relative frequency for making a pie chart. So looking at this is 0.4 or 40%. So I would draw a little less than 50, right? A little less than half. Just draw by here. So okay. So 40%. Now, okay, this keeps happening. I have to figure out what's going on with this thing. Okay, hopefully it will work this time. Okay, and then 40%. This is half, so a little less than half will be here. This thing lets me. Oh, sorry about the delay. Hopefully it will work this time. No way. Not working. Okay, just give it a second. being rebellious. Now that's both. Let me try again. So 40. Okay. I think so. Yeah. Alright, so 40% is a little less than. Not again. A little less than. Okay, this thing is testing my patience. Okay, do it again. Let's try again. Hopefully it will work. Okay, it's working now. So 40%. This is what? Brown. And this is 0.4. Now let's look at black. Black is 30%. That's a little. That's like quarter of. Let's get it to do like this. If this team draw. So this is black. 0.3. Red is 0.1. Red is 0.1. So. Okay, this is a really poorly drawn diagram because it's not in proportion. Red is 0.1 and this is blonde. It's supposed to be 0.2, but this is not in proportion. See, we see why we use computer programs, right? Because we are not perfect. We humans are not perfect. But we're going to learn how to do this on Excel, and that will be a nicer way to go with this. But that's the basic idea. We use categorical data for, we use pie charts for categorical data because it's easier to see, right? This is not in proportion, but if you look at this, you see that brown has more than that. But anyways, it's easier to see. It's easier to visualize. So speaking of that, why don't we just move on to Excel, and I'll show you how to make a pie chart. Okay, so let's go to Excel. Okay. Alright, so let's make this a little smaller so we can see everything, and hopefully you can see. So let's work some examples. Let's look at another example of categorical data. So we are looking at an opinion poll. So as we mentioned before, poll is taken before election to analyze the support rate, right? So we're gonna say responses. Okay. And then we have frequency, and we have relative. This is relative frequency. Alright, so let's look at this. Just going to fold this. Responses were support, neutral, neutral, meaning they don't really support any. Oppose, meaning that they're against the candidate. And we're looking at frequency of 125 and 7751. Alright, so here in this case, frequency represents the number of people who support, right? And here, number of people who are neutral, and number of people who are opposing the candidate, right? And okay, so oops. So let's look at this. Okay, I'm just going to make this look a little nicer. Alright, and then we have total. Okay, so frequency. These are frequencies, and since we're looking at this, since we have to find the relative frequency, right? We have to get the total, right? Let's see. Total. How do we get the total? We add these numbers, right? And for adding, we use we discussed this just before, right? Sum. This is a function that we use. Open parentheses, and you choose everything. These three, because those are the ones that we're using. Enter, we get 280. Oh, you know what? I was just thinking. I think it might be easier for you to see. Let's make it a little bigger. Say 150. Make it a little bigger. Or 200 rather. Okay, I'm not sure if this is going on. Trying to zoom in. Looking for something. Okay, here. Here we go. So let's make it 200. Alright, that's a little better, right? I'm sorry if you couldn't see. Alright, so this is the total, right? 280. And how do we find the relative frequency? Well, relative frequency is the frequency in the category over total amount, right? So how do we do this? Excels are really easy. Excels are the most beautiful thing in the world because they calculate everything for you. You just have to give them the formula. So whenever we're using a formula, we use equal sign, and you might be tempted to do like 152 divided by slash is a divided, right? 280. But this is not how we're going to do this. We know how to do this, right? This gives you the right answer, but why don't we just use the function? I mean, it's already here. So what I'm going to do is I'm going to click on this number. So when I click this, okay, it selects the cell. So B2, and this is a cell selected, right? B2 divided by the total, 280, B5, and then you enter. Then you get the frequency. See, this is the same number, but it's easier for you because, okay, so if you go to the bottom right side of the corner, the cell, you see the plus sign here, right? You see the black plus sign. And usually it's white one, but if you go to the dot, you see the dot right there. If you put it right there, your cursor, you see the plus sign. And what you just do is you just drag it down. Oops. Oh, I see. Okay, so there is a problem because let's look at the formulas first. So this is correct, B2 over B5. But what happens if you go to the next one? Let's look at this formula, right? It's dividing B3 and B6. Excel is very smart, so when you're going down, it just assumes that everything shifts down by 1. But that's not true because we're using the same value for total, correct? So what we're going to do is we have to lock this value. So although the blue one, right, B1 goes down to B3 to B4, B5 always stays the same. So what do? You put your cursor in between B and 5 and you press F4 button. Okay. Let me just, okay. I'm gonna screen cut this. Okay, so why is it not working? Right, so let's screenshot this. And then now we'll have it here. Okay, so just for you to see. Nothing fancy, but it's taking a while. Alright, so this is the what do you call it? The Excel, and I lost my pen. Sorry, this is, why is it not working? Okay, let's find my pen. Okay, whew, I found it. So let me write it down. So to here, see, to lock the value, you press F4 button. Okay, and that's how you lock the value. So moving on, if you lock the value here, enter, and then we're gonna do it again. You find the plus sign, you drag it down, and now we have a value here, right? And if you look at the formula, this one stays the same. It doesn't go down. Same thing here. If you look at this formula, we have 51 divided by 280. Okay, so here, as we said before, relative frequency adds up to 1. So if you sum it up, if you sum these values, and again, sum parentheses, open parentheses, and then you drag these values, close parentheses, enter, you get 1. And that's what we're aiming for. We always want to get 1 for this. Alright, so I think we're running out of time, so I'm just gonna end it here. Next class, we're going to learn how to display this this table, this chart, and we're going to use pie chart from Excel to use it. Okay, so for your homework, we're going to have you do similar things. Okay, we don't have anything fancy right now, but we're going to work on categorical values on Excel, so you can make frequency and relative frequency. Yeah, so we're gonna do that, and I'll let you work on your Excel. Please do explore Excel because we're going to use it a lot. All right, so so that's it for today, and I'll see you soon.